Yeah, hi guys. So till now we've seen like how to get inference and how to get coordinates, and we also seen how we can use any coordinate, like how we can use Pio to GUI to move our mouse, move our cursor to any coordinate we want. So in this video we'll be looking at this all the functions: move mouse, left click, right click, and hold and drag. And I think this video will be a little longer than the previous two because this move mouse function will take some explanation. And apart from this function, left click and right click are pretty simple. Hold and drag as well, it is simple compared to this move mouse. So let's just get started. Okay, so when we want to move mouse, we want some coordinates, like as we seen here, we had passed some coordinates 50 comma 0, and we have used this function from pio to GUI dot move mouse to move our cursor from here to 50 comma 0. So we want some coordinates, right? And we have got these coordinates, but we can't use all the 21 coordinates that are in here. So we definitely want to fix a coordinate, like we want to fix some coordinate, like let's just say I want to move mouse by using tip of my index, so index finger. So I will say I will extract x and y of my index, like tip of my index, and I will pass this coordinate to pio to GUI dot move to, and I will move the mouse. So let's just import pi auto GUI quickly. Import pi auto GUI, and once we have imported it, and once we got the coordinates, we can simply pass it as pi auto GUI dot move to, and the coordinates. So coordinates are x coords 8 comma y coords 8. The 8 is because of that is how it is indexed at. So 8th index represent tip of my index finger. So yeah, let's just run the code again, and this time I'm expecting that cursor should be moved as I move my hand across the frame. Okay, I think we have got some error. It says okay, so index out of range. So like what has happened, like it happened immediately. So my hand wasn't up in the frame, so x chords and y chords are null, like they are empty list. And I have tried accessing eighth element, like eighth index element in my empty list, so it won't work. So instead what we want to do, if length of x chords is 21, then only access it. And since x chord is 21, then y chord's length will be also 21. Like there can't be 21 x coordinates and 12 x chord 12 y coordinates. X and y will always have same length. So yeah, I will run the code again. And okay, so this time you see we got no error. I put my hand up here and look at my mouse cursor, so it is moving as I move my hand here and here. So you can see it is moving, right? But is this what we want? Is this is this the desired scenario? It is always moving. As soon as I put my hand up here, it is just moving all the time. We don't want that. We want a condition. We want some fixed condition which will identify, okay, now it is saying to move. It is not that you should always move it. You don't want that. So taking a step back, what we want to do is we want to fix some conditions for each mouse function. So we want to fix some gestures for each mouse functions. So let's just say for moving a mouse, what would be an ideal gesture? So it's quite simple. You would always use this, right? All your fingers closed, your thumb closed, and your index finger open. So apart from index finger, everything else should be closed and you can move. And in this case only you have to move your mouse. In any other case, whether it is this, you don't want it moving, or it is this, you don't want it moving. You want that these fingers are closed, your thumb is closed, then only you will move mouse. So how do we detect this? How do we detect if these four fingers are closed, if this thumb is closed, and if index is open? How do we narrow down on that? So take a look at this image and look at my hand in parallel. So take this is point 0.8, this is 12, this is 16, this is 20, and as I said earlier, y increases from bottom top to bottom. So this point is at lower than this. This point is currently at lower than this. So it may be 5, it may be 10, again it may be 5, 10, 5, 10, 5, 10. So when it is open, this point is low than this. So this point is smaller than this. The magnitude of this point will be smaller than the magnitude of this because y increases like this. And when I close this, 8 will go below 7. And since it has gone below, the magnitude of 8 has increased and it will be now greater than this. So can I say if y of 8 is smaller than y of 7, then it is open. And similarly, y of 11 is smaller than y of 12, then okay, so y of 11, if it is smaller than y of 12, then it is closed, and if y of 11 is greater than y of 12, then this finger is open. So this is how we can decide on open and close. So let's just have a separate function which takes all the coordinates and checks for the y of this and decides whether if this is smaller than this or if this is greater than this. So if it is smaller than this, it is open, and if it is greater than this, it is closed. So let's just do that. Let's have a separate function, call it okay, let's have a separate function and call it def get open status. This takes x and y, all x and y's, and it returns status. Yeah, and initially our status is, let's just put all things open. Okay, yeah, 4 and this one is 5. So yeah, we got all the 5, thumb, index, middle, pinky, and ring and pinky all as open. Now if y of 7, if this is greater than y of 8, y of 7, if this is greater than y of 8, then index is open. So for accessing status of index, status 1 open. So if this is greater than this, index is open, and if this isn't the case, then status close. Like y of 7 is smaller than this, so it means that this finger is closed, because if you check now, this is smaller than this. And similarly, we would have one more and one more. So yeah, we are keeping thumb aside for a second. I will explain the case for thumb after we have covered the finger. So just forget about the thumb, forget thumb exists on your palm. Just take a look at your fingers. So yeah, so this one for was the index, and this one is for a middle finger. So this should be 11. If y of 11 is greater than y of 12, then your middle finger is open, else it is closed. Similarly, if y of 15 is greater than y of 16, then your ring finger is open or it is closed. And similarly, if y of 19 is greater than y of 20, then your pinky finger is open or it is closed. And once we've done that, we return the status. And yeah, we only want to do this if x is of length 21. So if length of x is not equals to 21, just simply return null. No, don't return anything. So if it is not 21, then don't return anything, and if it is 21, then check for open and close case and return the status. So we've done that, and we don't want this because this is not a ideal way to do. And we would do something like status equals to get open status, and we pass x coordinates and we pass y coordinates. And once we got x our status, we just simply print it as print status. Okay. Yeah, so it is printing none because there is no hand in the frame. If I put my hand up here, it is printing all open. And if I close my thumb, it is nothing is happening because we haven't made a case for thumb. But if I close my index, it is saying close. Similarly for my middle finger, close, then uh, ring finger close, then pinky finger close. So take a look at output. It is working quite fine. I open my index, open, 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 then all these things. So it is working quite properly. So yeah, so this is about open and close thing regarding the fingers. Now to talk about thumb, yeah, we can make this code a little simpler, I would say. mm, like these are in, okay, we can simply do something like this, like for I in range, this should be from 2 to 6, and let's just say we want and this I should be multiplied by 4. So okay, just take this. For the first thing, we want I equals to 4 into I minus 1, and we want here 4 into I. So when I is 2, this should be y, should be 7, y of 7, y of 4 into 2, that is it. And then I will be maximum, I will take maximum value of 5. So here it will be 4 into 5 minus 1, that is 19, and 4 into 5, so 20. And instead of this 1, what we want is I minus 1. So I is ranging from 0, 1, 2, sorry, 2, 3, 4, and 5. So maximum I will be 5, so status will be status 4. So yeah, this thing, I think this works quite nicely. Let's just check if it is working. It's indentation, and remove this piece of code. Want the status, yeah. So this is for the fingers. Let me just write it for fingers. And we have set things, okay. Yeah, here as well we want I minus 1. I had skipped it. So let's just check it if it is working properly. Open, close, 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 and open, 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 and open. So yes, it is working quite properly. Now take a look at thumb. I would hide this output for a second. Take a look at this thumb. Okay, when I do this, when I close my thumb, uh, you can say that this point is going below than this, but it is not always the case. You can try holding your hand out and try doing that. It might end up just on same plane. So it is not always case. We don't want the y parameter here. We want something of which we can be sure of. So instead of y, can I say when I close my thumb, x of this tip gets higher, like gets greater than x of this. So when it is open, x of this particular tip, x of this thing is greater than x of this. But when I close this, so x of this gets becomes greater than x of this. So instead of y for thumb, we should opt for x. So let's just check if it is working, and we will make a case for thumb, and here we want to check x. So where that's image. Yeah, so x of 4, if it is smaller than x of 3, then it is open. And yeah, so if x of 3 is smaller than x of 4, then status of your thumb should be set as open, or else it should be like, if it is x of 3 is greater than x of 4, uh, so yeah, just a second, I think I messed up. X of 4, when it is smaller, uh, that is x of 3 greater than x of 4, so x of 4, yeah, this should be inverted. So when x of 3 is greater than x of 4, then it is open, and when x of 4 is greater than x of 3, so inverse of this condition, then it is closed. uh, I know it might have just gotten a little confusing for you, so you can pause the video and skip to some 5-10 seconds earlier and see the explanation for again if you are confused. But I hope you got it. So yeah, this is for the thumb, and I will run the code again to see if it works properly. Okay, so for fingers it does work properly, and for thumb it is currently set to open. I close it and it says close. So yes, it is working properly. So X condition is working just fine. So that is about open status of all the fingers and thumb. So we have done that. But is this enough? Like, is this correct thing? Let me show you once again. I will run the code. It does work. But what if I do this? It is always closed, and when I close it, my thumb is says it is open. So for thumb, take a look at the thumb. When I open it, it says close. When I close it, it says open. So it is inverted. So what we did here, this was our right hand, and when I put my left hand, this thing is always when it is open will be greater than that. So we have to check if it is right hand only, and if it is not, we have to invert the condition. So what we will do, we can simply have a flag to check if it is right thing, like if it is right hand is right. And how do we decide if your hand is right or not? So take a look at it. So if your hand is right, this particular point, x of 4 is smaller than x of 20. Rather than taking 4, let's just see this one, x of 3 or x of 2. I would say x of 2 is smaller than x of 17. Why I have not taken x of 4 and x of 20? The reason for this is, when I close my hand, there might be a case where I do this. So my hand would be right, but it would say that hand is not right, because this point might cross each other. So instead of doing tip of pinky and thumb, let us just do the base of 2, like base of thumb and base of your pinky finger. So I would say, if x of 17 is greater than x of 2, then the hand is right. And if it is not, like x of 17 is not greater, that is smaller than x of 2, then I would say that your hand is not right, it is a left hand. So let's just do that. So is right equals to x of 17 is greater than x of 2. So this is a Boolean expression. It should return true or false, So is right would have that. And we want this condition running only if, the hand is right. So if is right, do this. And if it isn't right, that is, it is left, invert the case, right? So when this is greater than this, it will be close, and when it was less than that, it should be open. And let's just see if it works. So for my right hand, no change, it is working properly, and for my left hand, it is working properly. So yes, we have got that right. You want to take a look at this right hand. If I flip it, it would work properly. So there's no issue of open and close, like getting a wrong status of open and close. So that is done, like great open status is done. So yeah, so this is how you decide whether your fingers are open or closed. Now let's just write a condition for this. For moving a mouse, what we want index is open and all other is closed. So this is the condition for moving the mouse. And yeah, you can also write this thing as like status equals to close comma, I'll just copy this, open, then 1 2 3. Yeah, so if this is closed, this is open, close close close, then only you are going to move your mouse. So how do we select this, like how do we check if this is the true condition? So to do that, let's have a separate function that should like check for all the conditions, like whether it has to perform this moving mouse condition, or it has to perform left click, right click, or hold and drag. So let's just have a separate function and call it perform mouse function. So perform mouse functions, and this function should take x coordinates, y coordinates, and status, and it should select which case it has to perform. So it would have this case movement, it would also have case left click, it would also have case right, and finally case hold and drag. Sorry. Yeah, so these are all the cases this function would be having. And just for a second, let's just have this variables called thumb comma index comma middle, then that's ring and pinky, and let's just have x4, thumb should be x4 comma y4, and similarly 2 3 4 and 5. The pinky should be x20 and y20. This should be 16, sorry my bad. This also should be 16. This should be 12, and index should be 8. So we can use directly these names, thumb, index, middle, ring, or pinky. We can directly use these names for each case. So in case moment, what we want to check if our status we had just passed is equals to this thing, close, open, close, close, and close. So let's just copy that and put it over here. So if status is equal to that, you should perform mouse movement. So to perform mouse movement, instead of directly calling pi or to GUI here, what I would do is I would create a separate function. The reason for that is because that separate function also helps in hold and drag case. So we again would have to move the mouse in hold and drag. So instead of repeating the code in this function itself, let's just have a separate function and call it case movement, and this case movement would be called here for only moving, and again we would utilize it here in hold and drag. So let's just have this separate function called def case movement, and it takes a single point as parameter, and it uses py_GUI dot move to function to move that point. So point, this should be 0, so point 0 represents x and point 1 represents y. So it should move our mouse to that, and this should be only done if the status is this close open close close close. So yeah, case movement, and it takes a single point which is index. So let's just see if this works properly, and let me just run the file again. Okay, so for some reason my cursor is not moving. Oh yeah, maybe because we haven't called the function yet, like we have created but we haven't called it. So let's just call that function. I will comment this one, print status, and once we have our x coordinates, y coordinates, I will do perform mouse functions. I will pass x comma y comma status, and this should, okay, so this should be x coords, y coords, and this should work fine. One more thing, if these are null, like if x coordinates and y coordinates are empty list, then this thing would raise an error. So instead of directly doing this, we should check if the length of x is 21 or not. So if it's not equals to 21, just don't do anything. Else if it is 21, you can proceed further with all the functions. So now I think it should work fine. Okay, so as you can see, the cursor is moving and it is detecting my hand quite properly, and the cursor is also moving according to my index finger. And if I do this, it doesn't work. Even if I do this or do this, it won't work. But as soon as I do this, it works, like it triggers our cursor into movement mode. So yeah, is this enough? Is this thing enough? I would say no, because take a look at this. If I move my hand up, the cursor is going to the top, that rightly, but I move my hand down, cursor only goes to some length. It doesn't go all the way to down. And why is this happening? See, same with the x. If I go till here, it goes to some x, but if I go till here, it should ideally be gone to at end of my screen, like but it is not going there. So why this is happening? Well, the reason behind that is your image size and your cursor, your whole screen size are different. So let's say your image is of size 0, sorry, not 0. Let's say your image is of size 10 comma 10, like 10 in height and 10 in width. So that is your image, and your screen is 100 comma 100, like 100 in width, 100 in height. So the only values you can extract from your image is maximum will be 10 comma 10. So, and when you use these values that are ranging from 0 comma 0 to 10 comma 10, you can move your pixel only between these values, like 0 comma 0 to 10 comma 10. It won't ever cross your maximum height or maximum width value. So what you want to do, you want to map your this 0 comma image width to 0 comma screen width. So take a look at this. I would go with some simple demonstration. So yeah, so let's just say this is your screen, and this thing here is your image, and what's happening here is your screen is of size 0 comma screen width and 0 comma screen height, right? So this is screen height and this is width, and your image is of this size, image height and image width. So what I want to do is I want to map See, your image coordinates would start from here, right? So this, for your image, this would be 0 comma 0, and for your image this would be image width comma image height, right? So what I want to do is map this 0 comma image width, this x thing, x is ranging from this. I want to map this to 0 comma screen width, and similarly the y, which is currently ranging from 0 comma image height, I want to map this y to 0 comma screen height. So this is all the mapping I want to do. Like x should be, x is taking value from this, but it should take value to this, and y is taking value to a value in this range, but it should take value in this range. So basically this is called concept of interpolation. So let's just say if your x is in certain range and you want this range to increase, so this is what we are going to do. And how to do, the most efficient way to do this is by using numpy library. There is a function in numpy called np dot not np dot, but there is a function called enter, which interpolate these values from 0 to image width. You should be able to achieve 0 to screen width. So let's just do that. So you got your point, and I would say x equals to point 0 and y equals to point 1. Let me import numpy here. Import numpy as np. This should do just fine. So yeah, so how do you use this function? So what ideally you would do is x equals to np dot enter, and you should give the current variable, that is x, and you should give the original range, like what values it is currently taking. So currently it is taking from 0 comma image width, and what is your desired value? So your desired values are 0 comma screen width, right? And similarly for y, this should be 0 comma screen height, and this should be 0 comma image height. Like the original value for y, the original range is 0 comma image height, and the desired range is 0 comma screen height. So this will be for y, and whatever the result you get, you use those results to move your cursor. So instead of point this, I would say this. So now it should work just fine. Okay, but see, we haven't declared what screen height is or screen width is. So remember we used this library PyAutoGeo, and as I said, like you can extract size of your screen using this function called size. So you can simply do PyAutoGeo dot size, and it should give you width and height. So let's just have some global variables called screen width comma screen height, and this is PyAutoGeo size. So this sorts this thing. But what is your image height, and what is your image, what is your image width, and what is your image height? Well, this depends on the camera resolution. So if your camera is of 480p, then by default your image is going to be of size 640 cross 480. If your camera is of size 1080, then your by default the image size would be 1920 cross 1080. So it depends, and for my case it's 480. So I could just write 480 here, and I could just write I could just write 480 here, and I could just write 640 here. But instead we can simply extract the image height and width, and can pass it here. So simply do this: image width and image height. and this function is called from here, so we would need to change that as well. And yeah, so and let's just to access this, let's just give image width and height to perform mouse function, and we extract image width and height from here. So this should be equals to frame dot shape, only two values. So okay, so this would be inverse, like it gives you image height first and then the image width. So yes, now this is sorted. Image height, image width is extracted from frame, then you pass this image width and height to your perform mouse function, and this image width and height are passed to your case movement function. Well, I think even if we didn't pass it here and like pass it here and just kept it as is, it should do just fine. The this case movement would be able to access it, but uh, to make it code more readable, let's just pass it. So what we done, we got the image width, image height, and we have passed it, and in here we have passed it again, like we have passed image width and image height, and using this we are using this function called enter. We are basically performing and linear interpolation, and we are interpolating x from this range to this range, and we got our screen width and screen height by using this function called pi.gui.size. So now let's check again if it is working properly. I will run the code again, and as you can see it is okay. So you seen earlier, like my cursor wasn't going right to half of my image, but it is currently at this side. So if I do this, it is going to the maximum x. If I do this, where is my cursor? Yeah, for some reason it is lagging, but I don't know what's the issue. uh, yeah, so it is quite jerky, I would say. Like you can see that it fluctuates a lot in result. And what is happening, what might be happening here, if you notice carefully, like when my hand gets still here, it stops moving, like it isn't moving. The reason for that is, I think, this take a look at my thumb and take a look at my index. We had that condition settled for if it is right then do this, and if it is not right, so the thumb open case is, I think, fluctuating it. So I would do instead this, I would just flip my hand and I can try to move it there. So in the corner cases there might be fluctuation if your camera is not that good, but you shouldn't face any difficulties if you have a decent camera, because you look at the result, it is quite fluctuating when I do this. So you don't want that to happen, like you don't want to get to the edge case, to extreme edge case. So you can see, like the interpolation has worked quite nicely, and we can range our values from 0 to x 0 to, sorry, screen width, full screen width. But it is still jerky, I would say. Like if my x is there and I put my other hand and I take it suddenly away, then it jerks. That jump from there to there is quite fast, so we don't want it to be that jerky. So we can do something about it. But before doing that, let's just fix this. When I do this, it moves, but as soon as my hand gets somewhere around here, it stucks. And in addition to this, take a look at when I try to access the corner of my screen, I'm not able to. Like I want to access the bottom right corner, and when I do this, I won't be able to get that because my hand will go out of it will go out of range. So I don't want that to happen. So what we can do about this situation, like not going, like not able to accessing the corners, what we can do about this is we can have some rectangle in our frame, and instead of interpolating from 0 to screen width, sorry, 0 to image width, we can simply bound those rectangle boundaries and interpolate them from to 0 to screen width. So instead of using image width, we will use the width and height of that particular rectangle. So let me elaborate what I'm saying. Uh, so yeah, this is your code, and take a look at this again. So yeah, now what we have here is this is your screen, correct? And then here's your image, which I intentionally hadn't drawn a very big. And what I want to do currently is I want to draw and rectangle, with same centers, like this as a rectangle and this rectangle would have same center. So I want to do that, and let's just say if the width of this your image is w and height is h, then I want my rectangle's width to be w by 2 and height to be height by 2. And this point should be at the center of it. So can you guess what would be the coordinates of this rectangle? So the coordinates of this rectangle would be so let me just do the calculations. And if the width is 2, this is half of the width, this is w by 4. So this will be w by 4, like I'm talking about this point, the top left, comma y is 0 there, and your bottom right would be sorry, this one would be 3w by 4 comma h by 2. So this would be 3h by 2, and I think I have got this thing right or wrong. So it should be w by 4 comma h by 4, and it should range, and the right corner should be this 3w by 4 comma 3h by 4. So yeah, so what you want to do is you want to draw this rectangle on screen, and you have all the corners. So to do that, you can simply draw it on a screen in the while loop, where it is. So yeah, here. So before after you got your frame, you can simply say frame equals to cv2. I don't think you need to assign it. You can simply do cv2 dot a rectangle. It should take the matrix frame, and it takes 0.1, that is your left corner. So this is width by 4. So you have got your image width. So image width by 4, and your height should be image, so your y should be image height by 4, and your 0.2 would be image width. So this should be 3 into, where is the 3 into image width by 4 comma 3 into image height, something's not right, yeah, 3 into image height by 4. Okay, so that's your 2 points, and let's just give color as green, B G R, and it's just a thickness is 1. That should do it. And yeah, so let's they should draw the rectangle, but we still would need to interpolate it. So I think there's some error here. Okay, so it was not defined. I'll get this. Yeah, let's just try that again. Okay, so it is, I think, expecting a point to be of integer type, and we have just given it as type float. So instead of this, we can make it as integer type. So we will use this, and this should give it an integer value. Okay, so this is working, and you see that rectangle is drawn there. And now what I want to do, I want my cursor to be bound by this rectangle. Okay, now I don't want to go all the way till here to access the corner, but I want to go till here to access the corner of my screen. Similarly, I want to bound this y-axis as well. So you know the coordinates, and you know how the interpolation works, so we can simply do that. So instead of interpolating from 0 to image width, what we can do is interpolate it from image width by 4. So this is the your minimum axis. Like the original range would be this, like image integer of image width by 4, and 3 into image width by 4. This should be mapped to 0 to screen width. And this again, instead of 0, let's start with image height by 4, and this should be 3 into image height divided by 4. Now whatever the values we get should be mapped to 0 to screen width. Now let's just do that. Okay, so I have a cursor over here, and it has directly gone to corner of my screen. Let's just bring it over here. It should be at a corner. So yes, if I go to the top of my rectangle, it is going to the top, and if I go to bottom, like here, okay, this won't work, but if I go to bottom, this is going to bottom. So we have successfully bounded the boundary of rectangle. Like, take a look at this x. It works like you can range it from here to all the way to your screen width. And if you feel this is if you want to constrain it in even smaller size, you can simply add some constraint. Like if I want to constrain it more by let's say 30 pixels, I would say, or 10 pixels, I would say. So let's just I would add in here, like the initial, this point would be added and the ending would be subtracted. So yeah, and here as well, let's just do -10, and the starting point would have +10. So this puts a constraint of 10, so that is the additional boundary of 10 pixels. You can play around with the values and find which one suits you best, and this should you should be able to do this quite nicely. So as you can see, I'm able to move my mouse all the way to like every corner by just bounding it to my rectangle boundaries. So yeah, this is the whole interpolation thing. But as you can see, it jumps, it still jumps. Like if I have my other hand here and I quickly put it away, so the mouse would go somewhere different. So you don't want that. The result is very jerky. What you want to do is update your X slowly. You want to move it quite slowly compared to what it is doing. So we can perform something called as smoothening. So to do that, let's we can have an global X and Y. Let's just call it location X comma location Y, and this should be simply pi onto GUI dot position. So wherever your current mouse is, like when you run the program, and wherever your mouse is, when this line is red, you would get location X and location Y. And as soon as you put your hand up there, the cursor would slowly move from the current point to whatever the X and Y your hand has given to the program. And we want this to slowly update. So here, instead of moving it to this, you can do something like location x is equals to location x plus x minus location x divide by some value. We should call it smoothening factor, and same for the y. And here as well. And we will move not to xy but to location x and location y, and we have to decide upon what our smoothing value could be. So you could say, let's just have smoothing value as 5. Let's just try with that. And what will happen over here is that when your x, let's just say you are okay, I will demonstrate this on drawing. Yeah, so take a look in this thing, like location x equals to what is it, location x plus x minus location x by smoothing factor. So if your location x is initially 0 comma 0, like your cursor is here and your hand suggests that your cursor should be here, and this value is 5 comma 5, like your x is 5 and your y is also 5, and this is the equation we are following. So what is going to happen here, like this is 0, okay, so 0 plus 5 minus 0 by smoothing factor, so this will give location, this will update this location x to 1, like 5 divided by 5. Then again it is still at 5, so this will move, instead of moving it to directly 5 by 5, we will move it to 1 comma 1, because it has updated by 1, and again now your location x has become 1, and this time it would be 1 plus this x, which is still 5, so this will be smoothing factor, so 1 plus this will be 5 minus 1, that is 4 by 5, so it will be something around, what is it, 4 by 5.8, so this will move to 1.8, so it slowly will move from here to here. Instead of, so initially what was happening, it was directly jumping from here to here, but now it is slowly moving. So that's what we want, the slow gradual update, and it should smoothen out the whole the transition from one place to another. So let's just check that if it is working properly. Okay, for some reason log x equals to log y. Yeah, we want to make it, we should have make it global, so let's just do that. Global log y and global log x. This should solve this error. Yeah, so see, my cursor is a little smoothened out, I would say, and it is not that jerky, and it is working quite nicely than the previous result. So if you increase the smoothing factor, you should see the better results, but if you have set your smoothing factor a very large number, the movement would be very very slow. So you can see it is working quite nicely now, and it slowly gets to the bottom and it doesn't jump. So that was about the smoothing factor. Let's just try to put our smoothing factor as 500 and see what happens. So this would get this would move your mouse very slowly. So yeah, where is it? So as you can see, it is moving very slowly, but gradually it's moving. So you want to settle upon some ideal value. 5 was working fine for me, so I will keep it. And yeah, so this solves our all the case movement thing. Now what we are left with is left click, right click, and hold and drag situation. I'll be continuing this in next video because I feel this video has gone too long. But yeah, check this out. We will be covering this, and yeah, see you in the next video, guys. Thanks.